So in the previous video, I showed you this slide of data, three different sets of data, and the upper set of data had the highest standard deviation. And standard deviation is loosely a measure of the distance, the mean distance, I'll say the average distance that the values are away from the mean. So in order to calculate the standard deviation by hand, you would need to calculate the mean. So what I'm going to do is I'm going to take this top set of data and I'm going to calculate the mean and the standard deviation by hand, and then we'll go through how the calculator can do it for us. Each dot in the dot plot represents one data point. So these two would represent that my original set had two zeros, 1, 2, 3 twos, and then 3 fours, and then 2 sixes. So if I wanted to find the mean, I would add all of these up. You hear in my voice like I'd add all these up because who wants to add these up? And then I would count how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And once I got that sum, I would divide the whole thing by 10. So sure, I could put this whole thing in a calculator, but oftentimes with these fancy calculators, I have people that they won't put the parentheses, they won't get the right answer. So we're not going to find, when I say use the calculator to find this, it was use one variable statistics, not, type every number at a time. And in fact, these numbers are small. 2, 4, 6 plus 4 is 10. That's 18. That's 24. That's 30. So I'm not even going to use the calculator to add those up, nor am I even going to use the calculator to divide. The mean is 3. So that's how I would calculate the mean without, just good old-fashioned arithmetic. Now, the standard deviation, if you look at our formula for standard deviation, it's either sample standard or it is population standard. And in this case, we have the entire population. I don't know what it is that these dots represent, but we are not needing to take a sample because there's only 10 items. And so I am just stalling a little bit as I write down the formula. And what we're going to do is I'm going to walk you through the different parts of the formula. And remember, I'm going to want you to do this by hand as well with the set of data that I give you. So what I need to calculate is that each one of these represents X. And I am going to take X and subtract it from mu. This is mu, not you, mu. And then before I sum all of the distances, I'm squaring them. And the reason the squaring works is because if you take a negative times a negative, it comes out as positive. If you take a positive times a positive, it comes out as a positive. So squaring helps us to care only about distance from center, distance from mean. Because it doesn't matter if I'm 10 less or 10 greater than, that's the same distance. Distance is never negative. And if I square a small number, it's going to be smaller than if I square a big number. So if all I care about is there great distance or not, then squaring it is going to keep that magnitude. The big ones that are far away are still going to be squared and have great distance, okay? So now what I'm doing is for every single, before you see me do this big square root and before you see me do the fraction part, instead of the summing, I'm literally going to put like pluses like you see me do. So every X, like this is the first X, I'll do 0 minus 3 squared. And then I'll do plus another 0 minus 3 squared. And then I'll do plus. And then 2 minus 3 squared. So the reason I keep using 3 is because 3 is our mean. And we're trying to figure out every single number in the list, its distance away from the mean. And so I'll continue plus and then 2 minus 3 squared plus 2 minus 3 squared. So that's gotten me 1, 2, 3, 4, 5 numbers in the set. I still have 5 more. Then I'll do plus 4 minus 3 squared plus 4 minus 3 squared plus 4 minus 3 squared. Continuing on, plus, I got my 3/4 there, right? Then plus 6 minus 3 squared plus 6 minus 3 squared. Again, putting this in the calculator is doable, but all these parentheses, that's insanity. I'm going to lose track. I'm going to hit the wrong button. And so once again, you're going to see that I'm going to subtract just, my good old brain. And what you're also going to see me do is, even though this is 0 minus 3, I am just going to write 3 squared because negative 3 squared is the same as positive 3 squared. All I care about is distance. When I'm doing this by hand, that is a mathematical conclusion that I would be happy that you made on paper. 0 minus 3 squared is the same as just 3 squared. So 3 squared, then I have another 3 squared. This is technically negative 1 squared, 2 subtract 3, but that's just 1 squared, and then I got another 1 squared, and then I got another 1 squared, and those are my 3 2s. And then I have 3 4s, and those would be positive 1 squared, positive 1 squared, positive 1 squared. 1, 2, 3, 4, 5, 6, 7, 8. I got 2 more, and those were the 2 6s that were originally in the set. 6 subtract 3 is 3. 6 subtract 3 is 3. We square that. So that's what this part of the formula means. What I just calculated right there was this part of the formula. You taking every single value in the set, subtracting it from the mean, that gives you distance from the mean, squaring it so that being greater than or less than doesn't mean greater or less distance if it's the same distance. Then we're going to divide this whole sucker by 10, and then we're going to take the square root of it because we were trying to backtrack. We squared them to begin with, and we want to kind of like unsquare the mess a bit. Not exactly accurate explanation here of what goes behind the formula, just generally, because again, you don't care about the arithmetic. You just want to see these numbers, where they come from, and be grateful that the calculator does it for you. Again, I want you to do it once by hand. I will not ask you to do it on an exam. Okay. So in a calculator, if I wanted to enter all of this in the calculator, the square root button is not a button. It's x squared is the button, and then directly above it is the square root symbol. So I'll hit the second function, and then I'll get the square root to appear. Then I need a set of parentheses, and that x squared button is going to come in handy now because I'm going to take each one of those and I'm going to square it. So now I've got 3 squared plus 3 squared plus 1 squared plus 1 squared plus 1 squared. 1 squared is just 1. So 1, 2, 3, 4, 5, 6. Yeah. Plus a couple more 3 squareds. And then I'm going to close the parentheses. And then I have to divide by 10, and this is all sitting underneath the square root sign. That's when I hit enter, and I'm getting this value 2.049. Write it down as reference here, 2.04939. That is our standard deviation, the typical distance that a value in the data would be away from the mean. And if you think about the mean is 3, if you think about the number 6, that's in the set. 6 is 3 from 3. My standard deviation is about 2. So it is giving you typically about how far away values are from the mean if you were to randomly pick a number from the set. So remember I said we are going to get the calculator to do this for us. So go back to our favorite button in this class, Stat, and edit. and this list is already set in there. Again, I would just type 0, but this is the set that I am that I just calculated the standard deviation for. So it's in there for me. Then when I go back to the stat menu, and I'm going to go to calc, and I want it to calculate our one variable statistics for us. And list 1 is the list where I entered my data, and so what you see is that 2.0493900153. That is shown in your screen right here with that symbol. That's your sigma x, and sigma is the symbol for our population standard deviation. Then directly above it is our sample standard deviation, which is just a slightly different formula. You don't have to memorize the formulas. You don't have to write them down when I give you a note card for your exams. What you want to know is what goes into the calculation and how is it useful. So how is it useful again? Mainly when we get to data that is normally distributed, we are going to be able to use the standard deviation to make predictions about how far values are away from the mean. So again, some useful data that is normally distributed. U.S. female heights, mean 5'8". Not me, right? Close. I'm close to the mean. I happen to be within 1 standard deviation away from the mean. But if you are below 5'5", then you are technically 2 standard deviations away from the mean and significantly short. You know, I'm leading into what values are considered significant in terms of standard deviation and normally distributed data. So we're heading into the meat of the class. When we get to about chapters 6 and 7, that's when we get into the really important statistics. And right now we're just doing the building blocks. The empirical rule, again, is based off of data that is normally distributed. And if you calculate the standard deviation and you have the mean of that data, 68% of everything in that population should fall within 1 standard deviation. 95% of the data lies within 2 standard deviations. 99.7% of the data lies within 3 standard deviations. I'm going to keep bringing this empirical rule back. You're going to want to know it. It's the most highbrow topic in your chapters 1, 2, and 3. I will end this video so you can take a look at that written work that I wanted you to complete.